Asset management is crucial to company performance in asset-intensive sectors. Traditional asset management or asset maintenance strategies relying solely on reactive or schedule-based actions no longer meet the business objectives of many facility owners in the energy industry or even in other industries such as transportation or manufacturing due to growing concerns such as aging infrastructure, financial pressures, regulatory concerns, and the loss of workforce skills due to retirement. Because asset decisions affect a wide range of business operations, decision makers must evaluate several planning horizons and trade-offs, one set of goals against another. Knowledge-based asset analytics can quantify the impact of various choice options on the key enterprise performance metrics. Asset health management, or otherwise known in the short form of AHM, is the study of how to manage the health of a single asset or a group of assets. To put it another way, it ensures that asset performance and the condition continue to satisfy business requirements. Condition-based maintenance is a critical component, in which maintenance is scheduled based on asset condition rather than on a calendar or working hour basis. This frequently includes procedures for determining asset health as well as time spent deciding what measures should be taken to manage the asset's health. This also involves a discussion about health at the end of life to guarantee that the asset is exploited to its maximum potential. When compared to the alternatives of regular scheduled maintenance or operating to failure, this technique has the lowest life cycle cost to numerous failure scenarios. Each of these jobs should be technically possible as well as financially viable in maintaining these assets. To evaluate asset health, condition-based maintenance necessitates an effective condition monitoring program. The measurement settings should be chosen to address the failure modes that have been identified, and data should be collected often enough to ensure early identification of failure. The most crucial part of the conditional management program is a method for ensuring timely remedial action. Asset health management encompasses a wide range of techniques, some of which may overlap in their intended scope and methodologies. Due to the usage of the same acronym to designate numerous different techniques and the use of the same approach with different names, asset health management has become a tough area to address. Furthermore, asset health management encompasses a variety of methodologies and components. And in front of you are the 5 general components. So the first one is a diagnostics for asset health, which are the techniques for determining the asset's current state of health. The second one is the prognostics for asset health, which are methods for predicting how the asset's health will evolve in the future. Third is maintenance. So maintenance, repair, and operations are all part of asset health maintenance. And this is actually better referred to as maintenance, repair, and overhaul. These procedures are used to maintain an asset's health, repair an asset's health, or restore an asset's usable life through considerable effort. And fourth component is the end-of-life asset decisions, and the fifth component is the disposal of assets. There are benefits in having an asset health management system in place in your company. Some of the advantages of effective asset health management is shown in front of you right now, which is lower total cost of ownership, assurance of sustained operational suitability, assurance that operations and maintenance do not introduce faults that could cause failures, elimination of defects, as well as failures are forewarned in advance, which allows you to have implementing corrective action to be conducted with minimal impact on your business's objectives. Now, a single subsystem with a single mode of degradation and failure is rarely found in assets in general, especially with the distribution assets that we will be focused on in this course. Most assets, therefore, are made up of several subsystems, each of which has multiple routes of degradation and failure. There may be one dominating mode of failure or numerous independent failure modes, depending on the nature of the asset. In some circumstances, an asset may only be designated end of life when numerous subsystems have deteriorated to the point where it can no longer be used. The composite health index algorithm must therefore integrate all condition elements to indicate the health of all subsystems or components in order to convey the overall health index of a system. This is accomplished via a multi-criteria assessment method that combines various characteristics into a single health indicator. The points shown in front of you right now are the most important goals in creating a composite health index. Firstly, the asset's suitability for continuous service should be reflected in the health index, which should be representative of the asset's overall condition. Secondly, rather than subjective assessments, the health index should include objective and verifiable asset condition metrics. And last but not least, the health index should be simple to comprehend and interpret. Now, all relevant parameters can be incorporated into an idealized condition-based health index utilizing a multi-criteria analysis approach. This entails putting the numerous components together and assigning important weightings to each one in order to create a unified health index. Each health index algorithm has criteria for evaluating subcomponents as well as specific tests and inspections. Now, before we move on further into our course, let us take a brief look at our sponsor for this course. Now, as an engineer, especially when I first started in my career, I really felt overwhelmed the list of documents that we need to do on top of our technical work. Yet, these documents are very important in our career as it is the more prominent thing that displays our credibility to management and to our clients if we so decide to become an engineer consultant, which is where the real actual money is. Now, I don't have these tools available to me when I first started my career, but now PM Milestone has created this package of all the professional templates that you need so that you can focus more on the technical aspect of your career. These templates are tried and tested by real professionals, so you should feel confident in using them in your career to present your best foot forward in front of your manager or clients. These templates are also updated periodically, and I think their last update is just 2021, so they're not going to be out of date or context to the present times, as these people are serious in getting the most professional product to meet your needs. They're also very confident of the quality of these templates too, as they offer you their product completely risk-free with 60-day money-back guarantee if you are not satisfied with it. So, if you are interested in this product and would also like to support me in creating these courses on YouTube in the future, please check out their product using the link in my video description titled Course Sponsor PM Milestone 2.0. There are two general rating systems to rate each health index component, so you may see some companies issue a letter grade while others issue a numeric score to rate various condition criteria and test results for the purposes of conditioning assessment. Now, in general, the quality of equipment and components can be graded using a letter grade from A to E or a numeric score from 4 to 0. With each letter designated the following conditions showing in front of you right now, where A or 4 is where the component is in perfect working order, B or 3 is when the component contains a few small flaws or signs of wear. The rating C or 2 is when the component has a number of small issues or one severe issue, and if left unaddressed, the discovered issues would hasten the rate of aging. Then we have rating D or 1, which is when the component has a number of major issues, and if they are not addressed, the in-service asset may actually fail. And lastly, the rating E or 0 is assigned when the condition of the component has deteriorated to the point where asset breakdown is imminent, and the asset must be therefore replaced immediately. In the ratings that I mentioned, qualitative terminology such as small, substantial, major, and severe, etc., are used to describe the extent of impairment of an asset's condition. Now, in all of these situations, modest asset impairment refers to when an asset can completely fulfill its intended functions on the system without impacting performance. Significant impairment describes a situation in which an asset's performance has dropped noticeably, but not to the point where it threatens public or employee safety, power quality, or supply service reliability, and the impaired assets can be repaired during the next scheduled routine maintenance activity. Now, the term major or serious asset impairment would be referring to when an asset's performance has deteriorated to the extent where it actually threatens public safety, reliability, or power quality, and the asset requires urgent repairs to restore its condition. The condition indicators are also given suitable weights based on their importance in establishing the asset's overall health and condition, as well as the ease or difficulty of improving these condition indicators. Those that are related to their major functions and cannot be easily improved without significant rehabilitation or repair work, for example, are given higher weightings than those that are related to supplementary functions or may be improved without high expenditures. Now, these numerical condition ratings, for example, A equals 4, B equals 3, etc., are actually multiplied by the allotted weights and then add together. The final health indices are calculated using the total scores. The health index is determined by dividing the overall score by the maximum possible condition score and multiplying the result by 100 for each component. On a scale of 0 to 100, the health indicators that were obtained can be then read and interpreted. An ideal asset, of course, would have a health value of 100, but a severely degraded asset nearing the end of its useful life would have an index that is close to 0 or a very, very low number. And finally, the health index formula can be represented as what is shown in front of you right now, which is health index equals to score calculated divided by the maximum score that you can achieve multiplied by 100. So now you have calculated the health index number. What now? Well, it is time to interpret these numbers. So now let's go over the table and look at these score ranges. First of all, if the number is between 85 to 100, then the condition is very good. And in this case, there are only some aging or minor deterioration for a very limited number of components. And what is required usually is just normal maintenance in this case. Now moving down, if you've got health index that is between 70 to 85, the condition is still good. In this case, there should be significant deterioration of some components, but these components may not be significant enough to cause anything substantial, and therefore only normal maintenance is required still. Then, if your health index is actually between 50 to 70, the condition for these assets would be considered fair. And in this case, there are widespread significant deterioration or serious deterioration of specific components. And if your health index number is around this range, you should increase your diagnostic testing for these assets and also should be ready for possible remedial work or replacement needed depending on the criticality of the said asset. Now moving down from fair, if your health index is between 30 to 50, the condition is actually going to be assigned as poor. And in this case, there are widespread serious deterioration in your asset. And if your index number is in this range, you should start planning process to replace or rehabilitate the asset considering their risk and consequences of failure. And lastly, for the range of 0 to 30 or anything that's lower than 30, the condition is going to be very poor. And in this case, there are extensive serious deterioration and you should immediately assess the risk or replace the asset as the asset is about to reach its end of life. And there you have it. That's basically the gist of health index. Now, before I end this video, the fundamentals section, I actually want to briefly touch base of the asset condition assessment. Now, asset condition assessment is a study of the age, design, construction processes, and materials used to produce an asset. A good practical asset condition assessment employs approaches that can be used to acquire meaningful information on the capabilities of various distribution system assets or the assets in your company and other industries to execute their intended activities safely and reliably. The data gathered can then be used to generate asset health indices and the likelihood of an asset failing in service in the near future, assisting in future asset repair, replacement, or having refurbishment decisions. The necessary information needed to calculate health index actually comes from 4 different sources for most assets, particularly in the power distribution asset. So these 4 categories are visual inspections, in situ testing, lab testing, as well as recent performance data. And even though that I'm keep on referring to power distribution assets, these would actually be general enough to apply to assets of other industries as well. Now, inspections conducted for, let's say, distribution with line patrols are regarded as effective and cost-effective method for managing distribution system risk. And in most countries, electric utilities conduct such inspections on a regular basis, ranging from once every 3 years to once every 5 years. And of course, in other industries, visual inspections is also the norm as well. Now, while major flaws discovered during such inspections are usually addressed with emergency repairs, other data on an asset. Now, if you like this video, please don't forget to click like and subscribe to our channel. Our channel, the EE Bootcamp, has a wealth of knowledge regarding to the energy industry, so be sure to check it out. Also, this video is part of a playlist of the whole course, and so I've put the link to the playlist for this free course in the video description. As you may be aware, I'm a professional online instructor that teaches various topics regarding to the energy industry and offers certificate of completion at the end of each course. As you probably have noticed, this course needs fundamental knowledge in basic asset management. Physical asset management is important and the skills are highly sought after in many large companies within the energy industry, or any industry that manages large asset in infrastructures for that matter. If you lack knowledge in physical asset management, look no further than my Physical Asset Management Fundamentals course offered at Electrical Engineering Portal, as in that course, I will provide you with the fundamentals that you need to kickstart your career in the physical asset management world. Another type of knowledge that you need for this course is fundamental information about the power distribution system. If you don't have enough experience in the industry, I would suggest you to enroll in my Distribution Power Engineering Fundamentals course hosted on Udemy, as in that course, I will walk you through the different parts of the power distribution system as well as basic design concepts that you will need to kickstart your career in the industry. Now, I have put the links to both of these courses in the video description also. Lastly, I've also included the link to my website in the video description that contains the information to all the courses that I offer, as well as other helpful resources that you may find useful in your career or in your learning path. Thank you, and I wish you good luck in your career. Remember, knowledge is power.